Now let's look at compound interest. Now compound interest is more interesting because this is a type of interest that is calculated on the balance that is already accumulated in the bank. So which means that you are going to receive interest on the money that you put plus the interest that they gave you before. So whatever balance is in the bank, you're receiving interest on top of that balance rather than the original investment you have. Which is why for things like pension funds, well, that one we'll put it aside a bit. For things like long-term investments, we usually look into the compound interest format because the more you leave your money to grow, the more you're going to earn as interest over the period of the years that follow. We'll take an example now just to make it nice and clear, and we will compare it to the one that we did for simple interest just to clearly see the difference between them. This one has an exponential growth, but for now let's just look at how do we go about calculating it in order to understand it before we get the formula. Now we'll take the example of 5,000 Rand is invested at 10% per annum compounded interest over the same period of time, which is 5 years. Now we want to calculate the balance at the end of the 5 years that would be in this particular account. So what do we do then? We look at year 1. So for year 1, it means that since the account only has the 5,000 Rand, 10% of the 5,000 Rand would be calculated. Let me write it this for the first. So we would calculate 10% of the 5,000 Rand, and that would give us 5,000 Rand plus an interest of 500 Rand. So this gives us a balance of 5,500. So that's the amount that we have at the end of year 1. Now let's go into the compounding issue. For the compounding issue, it means that when we get to year 2, we are now considering the balance that is already here. Let me just put it this way. And then we are going to take 10% of the balance. Again, let me first show it. And at the end of this, we are going to get that the balance, which is going to be, this one is going to be 550. So the balance would be 6,050. Compared to the simple interest, which would have been 6,000 at this point, we have an extra 50 Rand. But the point is that the amount of interest that is being added, so here just to confirm, is actually increasing over the years. So this is what makes this compound interest more interesting and better. Let's go on to the next years. So year 2, we would be starting with what, year 3, we would be starting with what we finished with in year 2, which would be the 6,050. We are going to add 10% of it. You can just divide by 10, you will find that it's 605. So now with the 605 added onto it, we find that the balance after year 3 would be 6,655. So again, the interest has increased from what we had previously. When we go to year 4, year 4 would give us, we're starting with this amount. So that would be 6,655 plus 665,5. Again, it has increased from the previous years. And this would give us a balance of 7,320,5. Then now let's look at the final year so that we can understand how the accumulated interest has become. So here we've seen that the interest has been growing. Now it's grown by 65,5 Rand compared to the previous year. Now let's do the final year. For the final year, which is year 5, we are going to have that we are starting with the 7,320 that we had, 5, and then we are going to add 732,05. Remember, it's 10% of this money, which is the accumulated money or the balance currently in the bank. That tells us that our final amount would be 8,052 Rand 55. So that is compound interest at work. So we can see that the interest has grown far more than the simple interest, and the amount of interest that is being added over the years is in itself increasing, which is why we call it compounding. So compared to the previous one for simple interest, which gave us 7,500 over the same period of time, this one has given us 552 Rand, 55 Rand more, 52 cents, sorry, more. So that is compound interest at work. Then now we will look into the formula. Again, we will use the formula for this example so that you can see how it works before we go into the more complicated formula. Now we are going to look at the basic compound interest formula, which is strictly for per annum compounding. So the compound formula is as follows. We are looking at the accumulated amount is equals to the principal amount times 1 plus I to the power of n. So now the n, or number of years, is in the exponent form. That's why we say it's going to present us with exponential growth. Now, let's look at the example that we had before. 5,000 Rand invested at 10% per annum compound interest for 5 years. Now, we would plug it into the formula as follows. A is equals to 5,000 open bracket 1 plus 10% or 0.1 to the power of 5, which is the number of years, and that would give us the 8,052 Rand 55 cents. You can plug it into your calculator and check. It's exactly the same one we did with our manual calculation from the previous example. So now you don't need to do the manual calculations. You can just plug it into this formula and it does the work for you, as you saw. Imagine when I say do it for 20 years, you need to do year 1, year 2, year 3, 4, up to 20. That's a lot of work. But this formula can do it for you straightforward and show you how much money would be there after 20 years. You can actually try it and see how the difference would be to the simple one, because the simple interest gave us 7,500 over 5 years, but this one is giving us 8,000 and some extra money over a period of 5 years. So imagine, or just calculate, not even imagine, do it practically, how much the money would be over 20 years. We know that for the simple one, it would be 500 times 20 and then add it to the principal amount. But for this one, do the calculation and then you will see compound interest is the way to go for your investments. That is why when it comes to loans, the banks don't ask you. They put you under compound interest because it benefits them the most. Okay, now we want to go into compound interest for the higher grades. Now this is where compound interest gets more interesting, because there's a different type of compound interest depending on the period or intervals in which it's going to be calculated. We'll talk about the difference in that. The formula that we have will be present in the formula sheet, but you would need to be able to manipulate it into how you need to use it based on your compounding periods. Now the change will be that we will still have accumulated value equals to the principal value, open bracket, 1 plus I. The interest will be divided by the number of compoundings per annum. And then the number of years will also be multiplied so that we can get the total number of compoundings for the whole period. So the n is actually representing how many times per year the interest will be calculated. So just remember it that way, please. How many times per 1 year will the interest be calculated? So for example, or just to look at the ones that we have, if they say compounded yearly, that means the m is 1 because it's once a year. Semi-annually or half-yearly, that means that the m is 2 because it's going to be calculated twice a year. Quarterly means that the m is 4, which means it's going to be calculated every 3 months, which creates the quarters, but 4 times a year. Monthly, it's calculated every month, therefore we are going to get 12 calculations per year. Daily is going to be calculated every day, which means we have 365 per year, leap year aside. Now, what does this mean? It means that if I, with my less financial education knowledge, invest my money in the bank compounded yearly, and you, with your newly gained knowledge of finance, invest your money in the bank monthly, then after 6 months, we both want our money and we are thinking of starting a business because now we've gone into business studies, accounting, we feel we can do this thing, man. It's the time to hold on to the opportunity. We've had the motivational speakers telling us, grab it now. So we went and we want to take our money out and go and start a business or do whatever else with the money. When I go, I'm going to get my money exactly as it was, because my calculation is only done at the end of the year. It's a per annum calculation. Whereas when you get there, you are going to find that your money has interest for 6 months. So that's where the compounding comes in, that it tells you when are they actually going to put your interest into the amount, but also in terms of the compounded, let's say the monthly, it means that every month some interest goes in, and by the time they calculate for the next month, they are calculating on the accumulated interest as well. So we will look at it next. that the actual effective, which means the real interest that you get for your money, is more than what is written on the paper. So that is interest for compounding. Now we want to do two things. So number one, I'll show you how to substitute into the compound interest given the compounding periods. Number two, I want to show you the difference between what we call effective interest rate, which is the actual interest you received on your money per year, compared to nominal interest rate, which is what is written on the paper. Now, let's look into this example so that we can have better understanding. 10,000 Rand is invested at 10% per annum interest, which is compounded. So that should be compounded monthly. Now, calculate the balance after 1 year. We need to do it for 1 year so that we can have a clear picture of it. So the balance after 1 year for what we had said, so this would be the solution. We would take A is equals to 10,000 Rand, open bracket, 1 plus. Now here, we know that it's 10%, so we have the 10%, but because it's compounded monthly, we need to divide by 12. The number of years is 1, then we multiply it by 12 for the compounding period, or the compounding times that the interest is calculated. Now, when we get the answer to this, we find that it becomes 11,047 Rand, 13067. Please just allow me to leave these decimals as they are so that you can see the picture clearly. So this is what we have as the money received. So the received money is 11,047,13067. All right, now we go into the second part. The second part is asking us, we know that 10% is written on the paper as the interest that would be received per annum, which is per year, but because it's compounded monthly, there's a difference that will be there. Let's see the effect. So what is the actual percentage which we are going to look at as the effective? What is the effective percentage that has been received by this particular person? Now, to get interest percentage, this is what we do. We take the money, so that would be our number 2. We take the money that has been accumulated, so that's the money. Then we have subtract the original money that the person invested, divided by the original money, and then you multiply by 100 to get it as a percentage. Now please punch it into the calculator and then you will see that it becomes 10.47130674%. Again, I will just leave this number as it is so that we can get clearly what I want to show you. I'll leave it as it is so that you can clearly see what I want to show you. So what does this mean? This means that the account promised 10% per year, which is per annum. However, the person actually got 10.47% as interest. That's good. Let's look at the formula for effective interest rate and nominal interest rate conversion. So remember, you can do it for effective to nominal or nominal to effective with algebra. But let's look at it in the normal sense that we would want to explain. Now, the formula says that in order to get I effective, you need to use the formula of I norm, which is the nominal, the written percentage on the document, divided by the number of compoundings to the power of the compounding. So we don't put the years at all. Minus 1, this will convert. Now let's take a look at how it actually works using the example we already did. Convert 10% per annum compounded monthly to an effective interest rate. So that would mean that we would need to put I effective is equals to 1 plus, here we will have the 10%, dividing it by 12 since it's compounded monthly, to the power 12 minus 1. When you put it in your calculator, you're going to find that it gives you exactly 0, or in this case 0.1047130674, which is exactly what we got under the real interest or actual interest for the previous example. Now, given that to get the effective interest rate, we call this one actually R. What you do, you take the I effective that you got and you multiply it by 100 to get it into percentage format. So that would give us 10.47130674%. Does it look familiar? Of course, because it's exactly the previous one we got for the real percentage. So I effective is the real interest that you get on your money when compounding is applied, and it is always more than what is written on the paper. When you go and invest your money, tell them to give you compound.